Welcome back. Today we'll be covering Chapter 3 in the textbook. As always, I will not be covering all of the PowerPoint slides, so be sure to review them all on your own. What we refer to as consciousness is really the sum total of brain activity from external stimuli and our internal mental activity. The level of awareness or consciousness that we have is determined by that system called the reticular activating system that we discussed in Chapter 2, while the content of consciousness is largely determined by activity in the frontal cortex of the brain. Consciousness can only focus on one item at a time, and it broadcasts it throughout the brain. However, unconscious processing can take place in many areas of the cortex simultaneously. Unconscious processing may also be responsible for many of the activities that we perceive as the result of conscious choice. For example, Benjamin Libet found that he could predict people's movements 150 milliseconds, that's thousandths of a second, before the people became aware of a conscious decision to move. That is, the unconscious mind produces a signal, a readiness potential, which is measurable before the individual becomes consciously aware of deciding to take an action. One's level of awareness and state of awareness determine the level of consciousness. And consciousness can vary from a normal waking state of consciousness to coma, vegetative state, minimally conscious state, locked-in syndrome, or various forms of intoxication. As noted before, consciousness is not determined by a single brain area, but is an emergent property that arises out of the activity of multiple areas of the brain acting in concert. A number of insults to the brain can result in alterations of consciousness. One of the more common of these is the traumatic brain injury, or TBI. This occurs when there is a blow to the head that causes an alteration of consciousness. When one is knocked unconscious, we refer to this as a concussion. The effects of multiple concussions are the focus of a great deal of study at the current time, and we are just beginning to understand the long-term damage that's caused by repeated insults to the brain. People in comas do not have sleep-wake cycles and do not respond to external stimuli, even painful external stimuli. Generally, comas will resolve within 2 to 4 weeks, though the recovery may not be complete. In the vegetative state, the individual will have sleep and wake cycles, will open their eyes, but will be unresponsive to the external environment. Any motor activity will be solely reflexive and not voluntary. Some persons who have come from a coma to a vegetative state improve to what's known as a minimally conscious state. In this state, patients appear to have awareness and responsiveness to the outside environment, but are unable to communicate directly their experiences to other people. All of us have limited attentional resources. That is, we can only focus on some things at one time. This involves both automatic processing and controlled or effortful processing. Because of the limited range of attention, people are sometimes subject to change blindness, or the inability to attend to all the information available from the environment at one time. For example, in a study from 1998 depicted here, a man stops to give directions to the man on the left who's holding the map. Eventually, two other men walk between the two participants holding a large board, and one of the men holding the board switches with the man who was asking for directions. In about 50% of cases, the subjects who were being asked for directions didn't notice that they were giving directions to a new, different person after this. Many of us are fascinated by the idea of subliminal perception, which is perception that occurs without conscious awareness. Though this does influence the information we get, it doesn't have major effects on our behavior. It can also be measured at the level of neuroanatomy. For example, with subliminal perception, the visual cortex is active for a very short period of time and then ceases to be active. With conscious perception, the prefrontal cortex is also activated along with the visual cortex and sets up a reverberating circuit that then broadcasts information to other areas of the brain. In the past, some patients with intractable seizures were treated with an operation that severed the corpus callosum, those fibers that connect the left and right hemispheres of the brain. These patients were referred to as, quote, split brain patients. Surprisingly, this operation does not disrupt much of cognitive functioning. However, there are some subtle differences that are of interest in terms of how consciousness works. To understand these, it's first important to understand that when we are looking straight ahead, everything that is to the left of center is projected to the right occipital cortex. Not the left eye, but the left visual field for each eye. Correspondingly, everything to the right of center is projected to the left hemisphere. Now, we know that language in almost all people is localized to the left hemisphere, so that the ability to understand speech and produce speech depends on information and functioning in the left hemisphere. In a series of fascinating experiments, individuals had images projected to either the left and or right visual fields. These were different images for each hemisphere of the brain. In split brain patients, in the example seen here, the left hemisphere would see a chicken claw. The right hemisphere would see a snow-covered home. The individual was then asked to point with either the left or the right hand to an item in front of them that corresponded to the image they saw. Individuals who saw the chicken claw projected to their left hemisphere pointed with their right hand, which is also controlled by the left hemisphere, to a picture of a chicken, explaining that a chicken goes with the chicken claw. However, these split brain patients who saw a snow-covered house projected to their right hemisphere pointed to a shovel. That's not what's interesting. What is interesting is that the explanation that they gave for the choice of shovel was that it was used to shovel out the chicken coop. The left hand, which is controlled by the right hemisphere, knew, quote unquote, that one uses a snow shovel to shovel snow out of a walkway. However, it did not have the information about seeing the house. And so the left hemisphere, where language is, confabulated a story about using the shovel to shovel out the chicken coop. This is an example of making a decision and then explaining it after the fact, and yet believing that they had made a conscious choice based on the logic that they're using in their explanation. The takeaway from this is that our explanations for our decisions are sometimes due to unconscious processes that we're unaware of. It's not that we're lying about what happened. It's that our brain has filled in an explanation that makes sense, and we simply are consciously aware of that explanation, but not where it came from. This is an important point that will be addressed in the discussion board this week. All of us sleep, or at least we hope we do. Complete lack of sleep is actually fatal. So let's talk about some of the things that take place during sleep. Humans operate on an approximately 24-hour schedule or rhythm. Circadian rhythms are those biological cycles that fit into more or less 24-hour patterns. One of these is the sleep-wake cycle, which is mediated by information from the external world. Light that strikes specific cells in the retina activates the suprachiasmatic nucleus of the hypothalamus, which is located just above the optic chiasm. This nucleus triggers the release of melatonin from the pineal gland nearby. And it is melatonin that is largely responsible for the feelings of drowsiness and sleep induction. We then go through a series of increasingly deep sleep that create a cycle that lasts approximately 90 minutes. First, we go into non-REM stage 1, stage 2, stage 3 and 4. We come back to stage 2, stage 1, and then we have rapid eye movement sleep, which is where our most emotional and dramatic dreams occur. The whole cycle then repeats on approximately a 90-minute schedule. As you can see, we have more deep sleep, slow wave sleep, during the early parts of the night, and more REM, or dream sleep, later in the night. Most dreaming occurs in REM sleep, which stands for rapid eye movement. These dreams are more likely to be in color, to be strange, illogical, and emotional. Non-REM dreams occur during stage 3 and 4 deep sleep, and these are more likely to be normal, everyday activities. It is during these non-REM dreams that people are able to engage in sleepwalking. During REM sleep, most people are essentially paralyzed so that we can't act out those dreams, which is a good thing. There are a number of theories about what dreams mean, and the most commonly accepted one is the activation synthesis theory. This holds that dreams are the result of the brain's attempts to make sense of this random brain activity, in which the emotional parts of the brain are very active and the logical parts of the brain are less active. Problems with sleep are fairly common. One of the most common is sleep deprivation, which tends to have negative effects on our alertness, our memory, our awareness, and to increase appetite, and particularly appetite for very sweet, high carbohydrate foods. Insomnia is a disorder characterized by difficulty falling asleep or staying asleep, and it becomes more common with aging. Sleep apnea is a particularly dangerous sleep disorder. Most cases are caused by an obstruction in the airway, though there are cases of central sleep apnea which are due to brain dysfunction. Narcolepsy is a disorder in which people have sudden attacks of sleepiness, such that they will become extremely drowsy or fall asleep randomly throughout the day. Sometimes these attacks of sleepiness are accompanied by a condition known as cataplexy, in which people lose muscle tone. If you remember that I talked about the different kinds of dreams in REM sleep and non-REM sleep. During REM sleep, most people do not move. Cells in the pons of the brain block the motor impulses and keep us from acting out our dreams. Those who have a disorder in this area of the brain may have REM behavior disorder, in which they act out those illogical emotional dreams. This can be quite dangerous to them or their bed partners. Sleepwalking is what occurs during non-REM dreams. During this time, normally you are not paralyzed, and so people will sometimes act out the dreams that they're having, which tend to be more realistic and logical than the REM dreams. Sleepwalking is extremely common among children, but decreases in frequency with aging. Hypnosis is a condition in which a person responds to suggestions and experiences changes in memory, perception, or action. There are two major theories about hypnosis, each of which has some support. The socio-cognitive theory is that people who are hypnotized are not in an altered state of consciousness, but are behaving the way that they are expected to behave. In contrast, the dissociation theory holds that hypnotized people are in an altered state of consciousness in which awareness is separated from other aspects of their consciousness. Psychoactive drugs are those substances which affect the functioning of the brain. As far as we know, throughout history and in all areas of the world, people have discovered that ingesting certain substances can alter their mental state. There are several classes of these drugs, including stimulants, which increase nervous system activity, depressants, which decrease overall nervous system activity, opiates, which reduce pain and produce feelings of pleasure, and hallucinogens, which alter perceptual experience or may even create perceptual experiences without sensory input.